Hey, it's Tony from Adafruit, and in this video I wanted to do another holiday themed project, just a real quick one, and this is kind of more experimental, just playing around with things, but I wanted to make a little NeoPixel fireplace, or like simulate a fire animation with NeoPixels, because it's the holidays, you want to have a nice warm fire, but maybe you're at your desk at the office or something, and obviously you can't have a fireplace in your office, although maybe you could. That could be pretty cool. But this could be like, take a little NeoPixel matrix, for example. Let me grab something like this. This is the NeoPixel shield, the Arduino shield, and I've shown this before. You can connect like a feather on the back that controls this, or just use an Arduino board, for example, like maybe the Arduino Zero, or if there's like an ESP8266 in the Arduino form factor. But I want to do this with MicroPython so that you can use Python code to simulate that fire animation effect. And also, by the way, for regular viewers, I've switched back to my old camera view just because I've moved some things around, so I don't have a good place to put the camera where it was before. But maybe I'll do some holiday cleaning and redo the whole setup. Anyways, though, so let's just kind of dive in. In this video, I'm just going to experiment with creating a fire animation effect on NeoPixels. And of course, we'll go back to my old inspiration. Let me switch to the main view here, and we'll see a few different things. So I've done a few other videos with NeoPixel animations, and I do a lot of things from the old demo scene, which was something in like the early 80s through kind of early 90s. It's still going on today, actually, where people would create code to make graphical effects. Things like 3D animations or neat animations like a fire effect or plasma we've looked at in the past. So I'll play real quick just a little YouTube video here that demonstrates the fire effect that I want to create. So that was a star field, and this is the fire effect, the old school demo scene fire effect. And so you can see it's pretty cool, and I'll go back to it real quick. It's a fire that kind of raises up from the ground, and it goes white up to yellow to red. It looks like the flames in a fireplace, and you can control the speed and the size of these fire effects. This is the plasma effect that I've done before, but this is what I want to do. I want to recreate this on a little matrix of NeoPixels like this Arduino shield right here. So that's what we'll jump into with this stream. Now, luckily, there's some really good resources out there to see how to create this, because you see that fire effect, and you can actually scroll down and see, like, here's kind of some static versions of it, and it looks a little challenging and complex. Like, if I wanted to start writing the code for that, I don't know where I would start. It's like random values. It looks like there's some filtering going on, and then how do you pick the colors? Like, you have to know how to transition from the red to yellow to white. So it seemed a little daunting, but I'll actually show you. It's really cool, and I'll put a link when this goes up on YouTube to this webpage, which describes in very nice detail exactly how this effect works, and it's probably much simpler than you expect. So I'll just summarize it and kind of say, so there are two components to it. One is how you pick the color, and this relies on the way computer graphics used to work a long time ago. You used to have a palette of colors where, nowadays when you look at your screen, you have like this beautiful, maybe even 4K or 5K screen with thousands and millions and tens of millions of pixels. And each pixel can be some 24-bit value, 32-bit value even potentially. And now we're getting like high dynamic range TVs and things that have even larger ranges of pixels. But way back in the day, we didn't have enough memory to do that on your video graphics adapter. So you just had maybe 320 by 200 pixels if you were lucky. And each of the colors that you could put on the screen was sometimes even more limited. Like, you might only have 256 possible colors. And so each of those pixels didn't even necessarily store the individual red, green, blue color component values, because that's a lot of memory. Even 320 by 200, remember when computers had like 640K or less of memory, you could barely fit an entire frame buffer into memory with that. So they did a lot of tricks, like you would use a palette, which is like a lookup table that says, okay, I'm going to take that 320 by 200 screen, and each of the pixels, instead of storing the red, green, blue colors, I'm just going to store a number, like a 0 to 255 number, a 1 byte value. And that's going to be an index into a table that I'll store my red, green, blue colors inside of. So I'll have an array or a table of 256 values that says, okay, here are all my possible colors that I might display on the screen. And then for each pixel, it just stores, okay, I'm pixel color 0. And so I'd go look up the first entry in that palette whenever I draw the screen. Or pixel, a value of 10 would look, 10 values into that palette. And you could set that color to any value. So you could make it red, you could make it blue, green, some in-between color like that. And that's how things worked, just to save memory so that each pixel didn't have to store that full red, green, blue value. And like I said, nowadays, doesn't matter. You've got gigabytes of memory, so it's no concern anymore usually to store that. But back in the day, that's what you had to do. And that actually works well in this case because you can create a palette ahead of time that has that nice ramp of white to red or white to yellow to red values, just like you'd see in a flame. And you can put that into your palette. So say your palette is like 256 colors long. So you start with, color 0 is pure white, and then maybe the last color is black. And then in between it goes in a nice gradient from red to, or from yellow to red to black, for example. So you can compute that, and then you just store all of your colors, not as the red, green, blue colors. You don't have to worry about computing those anymore. You just have to compute which of my pixel colors in my palette do I want to use. So the further I go into my palette, maybe the less hot the flame is. Because remember, fire is actually just something getting so hot that it gives off visible light. And there's a certain spectrum of colors that you see, and that's why a really hot thing looks white, like white hot. It's something you pulled out of a piece of metal out of a forge, for example. But as it cools off, it gets redder, it goes through yellow and then red. And I forget, if I remember my college material science classes, I would probably know there's more technical terms for this, but it's basically something gets so hot, it radiates that energy as light. And that's what you emulate with this palette, so that now my code is a little bit simpler in that I just have to know for each of the positions on this matrix, I'll just keep track of that one value, which is like the intensity effectively, and just use that intensity to look up in a color palette what that red, green, blue color should be. So that'll simplify the color logic so that now I don't have to think about, okay, how do I go from red to yellow, and as something gets hotter or cooler or whatever, I'm just gonna say, just keep track of that intensity and use a color palette to look that up. Now the other thing is, how does this animation actually work? How do you see these flames start at the bottom and rise up and change color as they go? And it's actually pretty clever. So this page describes exactly how it works. You have a grid and you store your intensity values in that grid, and that intensity values will say goes from 0 to 255. It could go higher or larger, but it's just the size of your color palette. And then you go through for each moment in time or each frame of animation, you look at each pixel and you compute its value, or you look at the intensity and you compute its intensity based on the pixels that are around it. And it actually shows right here, this is the formula that you want to use. So for a pixel right here in this top center, its value is equal to the sum of the 3 pixels immediately below it, and one to the left, one to the right, and immediately below, and then also 2 directly below it. So these 4 pixels right here, you add all those intensities up, and then you divide that by something. And it mentions here, you have to divide it by something that's a little bit higher than 4. Because remember, you're summing up 4 values. So if these were all maximum intensity values, like 255, you'd get a value that's larger than 255, which suddenly you can't look up in your color lookup table. You'll go past your palette bounds. So that's why if you divide by something a little bit larger than 4, then you know for sure, even if all 4 of these pixels are the maximum value, 255, or the maximum intensity, divided that by a little bit over 4, you're going to get a value that's smaller than that maximum value, because you're kind of averaging them out effectively. And then it talks about how that value that you divide it by kind of controls how high that flame animation effect goes. So it's kind of cool. If we go back to this animation, you can see it starts out really low at the bottom. So I'll play this again when it jumps to the flame. So you see it kind of rises up from the top. And so the value you divide that sum by actually controls how high your flames will get. And so we'll play with that. We'll see kind of how that effect changes, or how that value changes the animation effect. And then the last little key is, how do you kick this whole thing off, or how do you move this thing? And so the very last row, the bottom row, you just set to random values within that color palette. So some of the pixels might be like, a low value that gets maybe like a black or, a turned off kind of value. And then some of the other pixels on this bottom row might get a higher value that looks like maybe red or yellow or white. And so that's all you do. So you set that bottom row to random values, and then you just keep iterating with that exact same logic. So you go through and you just compute for each frame. You go pixel by pixel and look at all of its neighboring pixels to compute its new value. And that's how from the bottom, because you're always setting that bottom row to random pixels, they'll naturally flow up because this bottom row gets set to random pixels, then the row above it will kind of be influenced by the pixels directly below it, and then the row directly above that is influenced by the next row below it, which was influenced by the row below it. So you can see how it kind of chains, or it flows upwards in some ways, because each row is influenced by the row that's below it, and even the row that's two below it, but it's influenced to a lesser extent by that. So that's really all that is to this animation effect. And it's kind of fascinating how you just apply that simple little logic rule, but you get this really neat organic looking effect like that without having to think through of like, okay, how do I code this thing? Like I need some wisp of flame here, and how do I make it look natural? The key is you just have some simple rules here and apply them in such a way that naturally forms this kind of organic motion. So we'll kind of dive in, and that's the goal. I want to recreate this effect on this little matrix of RGB pixels. Now for this board I have on the back here, this is an ESP8266 Feather Huzzah. I think I've shown this a few times on some of the other videos that I've done with this, and I've just wired it to this NeoPixel Arduino shield. So this shield has 8 NeoPixels across and 5 NeoPixels down, so that's 40 NeoPixels total. And this shield I'm actually using the RGBW, so these are the 4 component pixels, but I'm not going to use the W, the white pixel. So in this example, the code, it'll be a little bit different. I'll mention where it's different. If you could use the RGB pixel shield and not worry about using the RGBW one. Okay, so we'll dive in then. Oh, and also, by the way, I've loaded the latest version of MicroPython.org firmware on this. It's 1.8.6. So you make sure you want to have that, and you do have to have that if you're using these RGBW pixels, because the later versions are the ones that support the RGBW. Earlier versions of MicroPython on the ESP8266 don't support the RGBW ones. They only support RGB pixels. So in most cases you're probably fine, and unless you have the RGBW version, you can probably use any version for this. Okay, so we'll kind of dive in here. Now I've started off with a little bit of code already. I put in, these are some functions that convert from HSL, or hue, saturation, and lightness, to RGB, or red, green, blue colors. And so this is just, there are multiple ways to represent colors. Red, green, blue is one way to represent it, but HSL is one way, HSV, or hue, saturation, value, is another way. And they just have different strengths. So HSL is nice in that this hue component, as this changes, that changes the color dramatically. The saturation, I think, controls how gray or how intense the color is. A low saturation value looks, I think, more gray potentially, if I remember correctly. And then the lightness value controls, I think, how white the value is. And so it's just another way to represent color. You can convert between these freely, and it's you'll get the same values as long as you convert HSL to RGB, and then if you do the inverse, you should get exactly the same values back for this. But basically I just plug these functions in because they're not really interesting, and that's not the point of this stream. I found these from a really nice little website that I'll link to right here. This is a JavaScript implementation of them, which I just converted into Python over here. So we'll use this, but we won't really dwell on it, because if we look at this fire effect, so like I said, the two things we have to do, now this code is written in C, and so I'm just gonna effectively kind of convert it into Python, but I'm really more just using their description up here to power my implementation, although it is nice to see a reference here to see how to do this. But like I said, there are really two steps here. The first step is generating that color palette, which they do right here. So they have 256 values, and you can see how they do this. They actually use this HSL to RGB, so they use the HSL color space, And it's kind of nice. So they just go through those 255 values, 256 values rather, and they just say, okay, let's grab the hue, and we'll let the hue go from 0 to 85, because that gives you a range of red to yellow values, it seems. And so you can see here, they basically say your hue value you take as your X value, which is your 0 to 255 value, divided by 3, so that 255 divided by 3, I'm guessing gives you something near 86 or 85. So that'll give you a value that ranges, your hue will range from 0 to 250, or 0 to 85 rather. Your saturation, they say, is just always the maximum, 255. So you always want that most intense color value. And then lightness, they basically ramp up from 0 to 128 for the first half of the color palette. And then for the second half of the color palette, they max out the lightness to 255, which means that you get a pure white pixel value for this. So it's kind of interesting how they do that. And that gives you that nice gradient from, I think it starts from actually black, from dark, up to like a dark red to yellow to white. And so that's kind of the heat values, if you think of it, you know, like something super hot is white, and then something that's not hot at all is not going to emit any light, so it's going to be dark, and then you get like that red and yellow gradient in between. So let's start by doing that. Let's just generate this palette. We won't even display anything yet in our code, but it looks like it's pretty straightforward. We just need to effectively recreate this loop right here. So in our code, like I said, I have these two functions that are going to be useful, but let's just start putting in some code here. So let's create a color palette of flame colors. The cool thing is too, you know, I could change this. Maybe we'll do this if there's enough time. I can change that hue value. So instead of going from 0 to 85, you know, maybe I go from 85 to 170 or something like that. And that'll just dramatically change your colors. So you could have like different colored flames potentially, which is kind of neat by using that color lookup table, you know, just changing what colors go inside of there. Okay, so let's make a palette object. And this thing is going to have 256 values inside of it. But I'm just going to start it out as an empty array. And let's see, let me just move this up a little bit so it's in the center of the screen. Okay, so let's go through each of the values in my palette. Like I said, I'm going to have 256 values. And let's just say, let's convert their code directly here. So I want to convert that HSL value. I'm just going to copy this out to my palette value. So let's do palette.append because the array starts out empty. So I'm going to add 256 elements to it. And then for each element, I basically want to use the value, the HSL to RGB function. So I'm going to call that HSL to RGB. Now my HSL to RGB function, it takes in the hue, saturation, and lightness as values that range from 0 to 255. That's what this code expects. But be careful because some HSL to RGB functions expect you to pass in values that go from 0 to 1.0, like a floating point value. And so that you'd get really weird bugs in this case. So make sure you know the ranges that you expect for this. Okay, so I'm going to call that HSL to RGB. Now in their code, they actually convert something, they have to create this HSL color object. I don't need to do that. My function takes in directly the hue, the saturation, and the lightness inside of here. So they start out with, you basically take the X value in their code. Well, here I could make my code exactly like theirs. So we'll say X will be my loop iteration variable. So X is going to go from 0 to 255. Now they'll set the hue equal to X divided by 3, but be careful because this is C code that I copied it from, and in C, if both sides of your division are an integer, you'll get integer division. In Python, Python 3.0 specifically, and MicroPython, if you do division, it will always be floating point no matter what, unless you do double divide, divide. So I do want to be careful, at least just to keep the same logic as the code that I'm kind of porting this from. So I want to make sure I do integer division, so I'm going to do the double divide right here. So this is basically going to take my X value, which normally goes from 0 to 255 because that's the range it's going to loop through, but it's just going to scale it down by 3. So, you know, it's just going to go up to about 85 or so, like they showed or they mentioned in the description. Now, the saturation value, like it says in the description, is just always fixed to 255, so that's nice. That keeps it simple. And then the lightness value, this is kind of clever what they do. So they use the minimum function, which in Python, it is the same function, just min is what you can call it. So it's going to pick either 255 or my x value times 2. And so that's basically going to say, okay, take my x value, my current x value, which goes 0 to 255, and just multiply by 2, so double it. So position 0 I get 0, position 1 I get 2, position 2 I get 4, and so forth. So it's going to ramp up, but then once it gets to position 128, that times 2 is going to give you 256. So this side of my minimum function is 256. And so the minimum of 256 and 255, well, now it's going to start picking 255. So this kind of clamps the value. It just means that I'll never get a value larger than 255, because once I get through half of the values in this range, they're going to be larger than 256. Position 129 is going to be 129 times 2, which is going to be like 258 or so. So that's going to be larger. But this minimum function is going to say, okay, I don't want that large value, I want the small value, which now is 255. When the values are lower than that, obviously, when x is below 128, it's going to get a value that's less than 255, and so it's going to pick this side of it. And so that's how it does that kind of clamping logic that it mentions here, where your lightness, it's going to start out going from 0 to 128, and then halfway through the range, it's just going to set itself to 255, like maximum brightness effectively for this. So okay, so let's do that, and then let's just fix our parentheses to make sure I get the right number inside of there. So that looks like it's correct. Okay, so that's my palette, and then let's just print out my palette as I go, just so that we'll see the values here. So we'll say palette X for this. And so this is actually how in a moment I'm going to look up a color value. So if I have any value between 0 and 255, I can index into this palette array, and it'll give me that RGB color value. It's going to print it out. So let's save this, and then I'm going to run this function. I'm just going to use the ampy tool, and I've set this up ahead of time, so I have my port. If I echo my ampy underscore port environment variable, this is pointing to the serial port for this board that's connected to my computer. So I'm going to use the ampy run command to run fire.py, and let's see what happens. Okay, so this is showing me the output of my script that I just ran. And so we see a bunch of stuff here. Whoa, actually, it's scrolling too far. I hate how my mouse has too much inertia. It just keeps scrolling sometimes. Okay, so this is value 0, which I get a color of 0, 0, 0, 0. Now there are 4 values here because, like I mentioned, I'm using RGBW pixels. And so this 4th one is the white pixel color, which I'm not using. It's always going to be 0 here. And that's actually because in my RGBW function, I just set it to 0 here. So, or in my HSL to RGB function, I set it to 0. If you're not using the RGBW pixels, take this out. So just delete that. And actually here, I'll rerun this just so it looks, you'll see the difference here. So you don't get that W value inside of here. Okay, so you can see, these are the color values that I'm getting. Now the interesting thing is, you can kind of see, for the first half of these, they're all, or the second half of these rather, because this is going in order from start to end. And so here's the end. The last half of these are all 255, 255, 255. That's white. That's a pure white pixel. And that's because we're seeing once that lightness value gets to its maximum of 255, I believe in the HSL color space, that's just a pure white value. It's like completely intense lightness. It's just blindingly bright, effectively. So that's why half of the values turn into that white color, which is interesting how the way that the palette works like that. But you'll see that that's the way this animation is supposed to work. But once I get to the lower half, now you can see the colors are kind of changing. And it looks like, for the most part, there's more red. This R component on the left here is larger than the green and the blue components. But the green component actually grows a little bit too, and so red plus green gives you yellow. So these should be kind of yellowish values in the middle. But then as I get further down, you can see, these are mostly red values, but a very dim red value with almost no green inside of there. And there's really no blue at all in here at all. So that's good. I really shouldn't see much blue. Although you do start to see some here, which is kind of interesting as it goes up through the colors. But anyway, so that's the color palette. There's 256 values. I can index into this from 0, which is like minimum intensity, to 255, which is like maximum intensity. And it's going to go from basically black to red to orange to yellow to white, which is the color of flames. So that seems good for this. Okay, so I've got my palette. Now the next thing, actually, before I create my palette, let's initialize my NeoPixels. So we'll initialize the NeoPixels. And to do this, I need to import a few modules. So let's import the machine module, and then let's import the NeoPixel module in my script here. And then this is just boilerplate NeoPixel initialization with MicroPython. We'll make a NeoPixel object, and this is from the NeoPixel module. And I need to tell it which pin. So machine.pin, and I guess let's be nice. Let's make these kind of values that I put at the top. So we'll say pixel pin equals, on my board here, I'm using pin 15. And then let's also put in the width, which is 8 pixels wide, and the height, 5 pixels tall. That's the width and the height of this pixel matrix. You know, I like to put these in as values at the top that I can easily change. So if I want to make this work on like a larger matrix or a smaller matrix, it's really obvious where I can just change this once in the code. Okay, so let's go back then, and then my pixel pin I need to pass in here. And then the NeoPixel object, it needs to know how many pixels to create. That's going to be my pixel width times my pixel height, because the NeoPixel object, it's not a matrix in MicroPython, it's just an array. So you have to flatten it out and say, okay, width times height, you know, width times height, that's the total number of pixels on this thing. So that's what I want. And then because I'm using RGBW pixels, I need to pass in a value of 4 right here, because that tells the NeoPixel class in MicroPython that there are 4 components instead of 3. The default is 3. So if I put nothing in here, it just assumes that you have an RGB 3-component pixel. But in my case, I have 4 component pixels, RGB and then W for this. So you do have to be explicit about this. And if you only have RGB pixels, leave this out. Don't include that 4. You just want the default of 3. Okay, and then I like to just turn off the pixels. So I'm going to fill with 0, 0, 0, 0, and I'm using 4 values because these are RGBW, and then write. So that just calls, after you set the pixel colors, you have to call write to send them out to the NeoPixel display. And I guess just to make sure it works, let's just set all the pixels to a like medium red intensity, and then we'll run our script. And okay, so yeah, looks like everything works. Everything lights up red like I expect. So let's set this back to 0, and we'll run our script again, and it turns off. So okay, so that's good. So we've initialized our NeoPixels. We've got our color palette created, and I'm actually just going to comment out. We don't need to print out the color palette values anymore. Okay, so let's make, let's create the fire matrix, because remember that, you know, the way that this animation works, I need to keep track of, for each of my pixels, that intensity value, which is just a value from 0 to 255, which is really just what I'm going to index into the color palette with. And then I have to be able to go through and compute each of the intensities based on the intensity of pixels around a pixel. So, you know, I don't really actually care about like my RGB, the NeoPixel color values. I'm really just caring about those intensity values. So I need to keep like a 2D array or a matrix of all of the intensity values. And for this, I was actually thinking, let's make this a class, because I need to effectively, in some cases, I need to be able to set the intensity of a specific pixel at a specific location. And in other cases, I need to get the intensity of a pixel at a certain location, because when I compute the intensity, I need to look at the pixels around it to compute that. And so it'll be a little bit easier if I make a class where I can just say, okay, create a matrix that's, you know, X pixels wide and, you know, Y pixels tall, and then give me a function I can call that lets me get and set each of the intensity values at specific X, Y positions inside of there. So let's do that. Let's make a little class that I'll call, how about fire matrix? And for this class, the initializer, this is kind of the constructor, this is going to take the width and the height of my matrix, because again, you know, I want this to be flexible. I don't want to hard code this in to be 8 by 5. I want to be able to change this. Okay, and so then let's do this this matrix. We're just going to store it as an array in Python. So let's say self.data equals an array with the value 0. And then this is kind of an interesting syntax that you might not be aware of in Python. If you want to create an array of a certain size with all filled in with the same element, you can create an array of size 1 with the element value that you want, and you can multiply it by a number, which seems a little bit weird, but if you run Python, you can actually do this yourself, like 0 times 10. This gives you an array that's 10 items large that are all set to 0. And it doesn't have to be 0. You could say, like, if I wanted none, you could do that. If I wanted some value like 1, like that, or maybe I want 100, you can do that. And this is actually apparently the fastest way to initialize an array. Oops, let me close out of here in Python. So it's a little bit kind of weird syntax, but when you see this kind of syntax, that's what's happening here. This is just creating an array of a certain size with an initial value. So this is just setting everything in my matrix to the value 0 as an initial state. And then let's make that get and set function. So the get function, I want to take in the x and the y position of my pixel. So in this case, I'm going to return my data. And then I've done this before in some videos. Basically, how do you convert from an XY position, a 2D value, into a one-dimensional value? Because this array just has one dimension to it, even though it stores that XY kind of 2D data. And basically, the way you do this, it's a very common graphics thing. You take your Y position times your width. So I'm going to have to remember that width and the height, actually. Well, actually, no, I don't technically need to remember the height. Although it doesn't hurt, so I'm gonna store it anyways. So I'm gonna keep track of the width and the height of my matrix. So I take my Y position times my width, and then I add my X position to that. So let's see, I'll put a little more spacing in here so it's a little more clear what's happening here. So you take your Y position times your width, because that's basically saying, okay, Y position 2 would be this middle row right here. And so if you're thinking of this as a one-dimensional array of all these pixels just going in order like my finger is showing here, right here, this position, it's 2 rows down, which is actually 2 full width rows of pixels added together. So that's why you're multiplying by your width to get this position right here. So it's, if you're not really sure, just kind of think through and test it out and write down like longhand, kind of write out the math for this, plug in like 0, 0 and do this multiplication and see what value that you get, and then try a value of like 10, 10 and see, how does this Y times width plus X change, because you'll start to intuitively kind of understand how that works. Now that's how I get the value, and then if I want to set the value for this, I want X, Y position, and then I also need my value that I want to set. And for this, I'm just going to set my data, my Y times width plus X, exact same formula to look up that position in the array, but now it equals the value that I pass in here. Okay, so that's going to let me create a matrix, and now I've got a nice little get and set function that I can pass in an XY position, and it'll give me the intensity value, or it'll let me set the intensity value at that position for this. Now there's one extra little trick though, because if you were thinking through this, if you've maybe jumped ahead, remember the logic is for each pixel you look at the pixels around it, but what happens when you're on the edge, like right here on this edge, I need to look at the pixels around it. Now I can look at the pixel below it, I can look at the pixel to the right, I can even look at the pixel 2 below, but how do I look at the pixel on the left over here? There's nothing there. And they actually say inside here, what you do is you actually just wrap around and look at, okay, what's the pixel over here in that case? And same thing on this side. So when I get down to this row or this column on the far right, and I need to look at the pixel on the right over here, wrap around to the left side here. That's one way to do it. You could clamp it and say, just always use like a black or a 0 intensity over here. But that might actually change how your fire appears. It may be something worth experimenting with. But that's what they basically say is, you know, when you get to an edge and if you want to index off of it, wrap around to the other side. And same thing with the height. They actually don't really mention it here, but if you look in the code, so when you get down to, or when you're at like this, or yeah, when you're down to like this second to last row and you're looking like 2 rows beneath it, like down here, you're actually going to loop back up to the top right here, which is a little bit weird because these are actually the less intense values, but you have to do something. And so I'm guessing the logic is just, you know, just wrap around wherever you want. Now, an easy way to wrap around is actually using the modulus function, because I'll show you this. If I run Python again, so if I take, like, let's say 10 modulo 255, so that gives me a value of 10. But what if I do 256 modulo 255? That gives me a value of 1. So the modulus operator, think of it as a way to constrain your values within that range so that once you get past 255, it will wrap around to a value that's still within 0 to 255, but it just goes back to the start effectively. So, you know, if I go like 266 modulo 255, I get 11, you know, so that's 10 past the value that I saw right there. So that's really cool. It also works with negative values. So if I go negative 10 modulo 255, 245, so that's cool. So that just indexed the opposite direction for this. And so that's kind of nice because when I get to this, you know, far left side, 1 to the left is -1, and so it's going to wrap me around over here to this side. So this is cool. So I'm just going to build this into my little fire matrix class right here. So whatever x value you pass in, I'm going to modulo it by your width, and then same thing for the y value, the height. So we'll modulo it by the height that we used right there. And then I'm going to copy that and just apply the same logic to the set function right here. So this is nice. This will make it everything wrap around. So if I ask for, you know, what's the intensity at position 0, 0, these modulo operators aren't going to cause it to wrap around. It's going to look up that pixel and give me the value. But then if I look up the value at position -10 on the x position, the modulo operator is actually going to wrap around to, you know, maybe 10 pixels from the far right now, and since this display is only 8 pixels wide, it's actually smart enough. It will wrap all the way around and then back around again. So I'll get, you know, a value like over here for that. So that's why I wanted to put this logic into a class like this, because, you know, it's not just a 2D array that I'm using here. It's an array with a little extra logic. Like, I want it to wrap around. I want to be able to get positions that aren't on the array, but have it do that wraparound logic for me. Okay, so now it's a little bit easier. Let's create our fire matrix, and let's say fire equals fire matrix, and this needs to know the width. So I'm going to use my width and height variables that I set ahead of time for this. So, and let me just scroll down. I hate how it always puts things at the bottom here. It's, you know, I guess text editors don't think about people who live stream programming. It'd be nice if I can position this wherever I want it. Okay, so I've got my matrix. Okay, so now step 1 of this, you know, before I start putting this into a loop, let's just do like 1 frame of animation for this. So it starts out by, you basically want to set the bottom row to just random intensity values for that. So let's do that. We'll start out and we'll say, okay, let's set the bottom row to random intensity values, 0 to 255. And to do this, I'm going to need to use a random function, which is in a different module. So on the ESP8266, the UOS, the MicroOS module, has a micro random function. It's a little bit of a weird function. I'll show you how this thing works. Actually, I'll connect to the REPL on my board. So if I go to screen, dev tty, so I'm just connecting to my MicroPython board right here. So if I import UOS, and I think I've shown this before, UOS has a urandom function, and you pass it a number. This is the number of random bytes. So this will return a string of random bytes. So if I pass in 5, this is actually giving me back 5 random bytes. But I actually want a random number from 0 to 255. So I can do that. I can say, okay, Python, convert this byte into an integer. So I can say uos.urandom, and I just need 1 random byte value. But I have to also tell it explicitly to pick index 0 here. So when I do this, and if I call this over and over, you see I get random values from 0 0 to 255. And the reason I'm doing this is because if I just call urandom.1, I get a byte string back. That's what this B syntax means. And even though there's only one byte inside of this, the int function gets confused because it just sees this as a string. It doesn't know how to convert a string into an integer. It knows how to convert a character within that string, because a character is just represented by like a byte value. It knows how to convert that into an integer. And so that's what this little index 0 syntax means. It just says, grab the first character from this single character string and turn that into an integer. And so that's how I get this random value like this. So it's a little weird. Unfortunately, I don't think they have the random module implemented on the ESP8266 MicroPython port. Although let's see if they do. Nope, they don't, unfortunately. And they do have a urandom module. It doesn't have the random functions that you might expect in Python. So it just has this get random bits function, which is even less helpful for us. So this prickly thing is how to get a random number that ranges from 0 to 255 on ESP8266 MicroPython. But that's all I need for my function. So, you know, who cares? It's ugly, but it works. Okay, so let's go through that bottom row then. So for x in the range of pixel width, and then let's just set my fire, and I want to set my x value, and then my y value is going to be my pixel height minus 1, because that's going to be the y value of that bottom row. And I want to set this to that random value that I had. So we'll say the uos.urandom1, and then grab the first character from within there, that weird little thing. Okay, so that's going to set my values there. Okay, so I set my pixels in the bottom row to random values. Now let's try to visualize that. So I want to go through and I want to set each of my NeoPixels to the color based on the intensity that I look up in that color palette that I created ahead of time right here. So let's go through and do that. Basically, what I can do here is let's loop through each of the pixels in my fire matrix. So we'll say for x in the range of pixel width, and then for y in the range of pixel height. So I'm just going to go through each of the xy pixels, pixel by pixel on here. And then my NeoPixels. So now I need to convert from the xy positions to that 1D array of NeoPixels. So just like the logic I had right up here, I'm going to do this exact same logic with my NeoPixel array. So I'll say my x times my pixel, oh, no, sorry, my y times my pixel width. Yeah, y times pixel width plus x. So this needs to equal a color value. And then I do want to be careful that I actually get my RGBW colors in here because I need 4 color component values for this. So this, now I want to look up in my color palette the intensity value for that fire pixel. So I'm basically going to call my fire.get and just pass in the XY position. So this is going to return back the intensity of the pixel at that position. And then that's going to use that intensity to look up inside my color palette that I set ahead of time what RGB color value I want. Because remember, that color palette has the RGB colors, RGBW actually. And then that's going to set the pixel at that position to that color. So that's what's happening here. And then I want to make sure that I call my NeoPixel.write function so that I can see this. So we'll say convert the fire intensity values to NeoPixel colors and update the pixels. We'll just describe what I'm doing. Okay, so now I should be able to run this, and hopefully the bottom row should light up with some random stuff. So let's exit out of there and let's run fire.py. And okay, so it's all white, but let's run it again and let's see what happens here. So now, okay, now you might not be able to tell because the camera is a little bit weird, but these pixels are red and then the rest of these are kind of white. And you know, I'll run this again and it's a little bit different. Here's an orange pixel, there's a red one, and then there's some white stuff. But this looks like it's working because, you know, remember when I looked at that color palette, half of the values are white. That upper half turn into white values. And then the lower values here are, you know, there's some red and there's some yellow and stuff like that. So it looks like it's working. I'm getting random values down there. That's what I expect. And it seems a little weird, you know, like how is this going to turn into that fire effect? But we'll see. You know, the next step now is I need to apply this logic. So I want to take a step, a frame of animation where I'm going to go through each pixel and set its value, computing it based on the intensities of pixels around it. So let's apply that logic next. I'm going to do this after I set the bottom row to random values, but before I print the pixels out. So let's just do one step of this processing here. So let's go through, and they are very careful to tell you, you want to do this from top-down order. You don't want to start from the bottom and compute your pixels up. You start from the top and compute down for this. So I want to basically follow that logic. So I just want exactly the same loop that I had before. You know, go through all the pixels in the X direction and then all the pixels in the Y direction. Pixel height. And I got a misspelling right here. So we'll fix that. Okay. And so for each of these pixels now, you can actually see how they do this in their code. They just say, just sum up the 4 pixels, you know, the one directly beneath, the one to the left below, to the right below, and then also the one 2 below. So sum those all up and then divide by something, and we'll look at that something in a second here. But okay, so let's start this out. So we'll say value equals 0, and then value plus equals, so let's start by grabbing the pixel that's, how about to the left and below with one position. So this pixel right here. So that one is going to be, I want to get my fire dot get the value at x minus 1, so that's 1 to the left. And then remember, it's smart enough, so it's going to do that wraparound logic automatically. So I'm just going to say, just grab 1 to the left, and then my y position 1 below. So, you know, y minus 1, so the pixel below and to the left of me. I want to get that value. And then add on to that, I want to get the pixel, you know, let's get the one that's right below me. So, you know, just y position minus 1, and then the same x position. So let's do that. So we'll say same x position, but y pixel 1 below. And then let's grab the one to the right. So it's, you know, going to be x plus 1, but y minus 1 still. And then the last pixel, that's going to be the one that's 2 pixels below me. So this one right here. So that one's going to be value plus equals fire.get, same x position, but now y minus 2. And again, it's, you know, it's going to be smart enough. It's going to wrap around where it needs to. You know, when it gets down to these bottom rows, it's going to snap back up to the top to figure out what pixel value that it needs for this, or what intensity value to add to this. Okay, we're not done yet though, because remember, we have to divide these by some value that's equal to, that's 4 or greater. And it has to be higher than 4, because if it's less than 4, there are some cases where you might get a value that's larger than 255, and you can't index into your palette with a value larger than that. You're going to get an error that you don't have a value there. Okay, so, and let's actually set my value equal to, because my value needs to be an integer. I can't index into my palette with a value of like 2.7. You know, it has to be either 2 or 3. It can't be in between there. So I want to make sure that I convert this into an integer, because remember, division in Python is floating point. So, you know, I can say value divided by, like, how about 4? And, you know, this is going to divide by 4, but it's going to be floating point division. Now, they suggest tweaking this value. So the larger you make this value, the smaller your flames will get. So let's make this a variable that I can change. We'll say, how about flame divisor equals, let's say 4.25. And, you know, we'll just throw out a value here and see how this works. So let's divide by my flame divisor. And okay, so that should be okay. So, oh, and then now I want to set the pixel. So I want to do my fire.set at the XY position equals this value that I just computed right here. So that's just going to go through and set each of the flames, each of the pixels based on the pixels around it. So, you know, again, just to summarize, so we're creating that fire matrix. We're setting the bottom row to random values. Then we're just going to do one step of the animation. So you're not going to see much at the top, but I should see that these top the bottom three rows actually should get some color values, because this middle row is going to be influenced by the very bottom row just very slightly, because it's only this very bottom pixel that will influence it. And then the second to last row is going to also be influenced by the bottom row, but it'll be influenced more because it's going to pick all three of these pixels, which are immediately below it in this case. So okay, so let's run this and let's see what happens. So I do this, and hey, oh, that's kind of interesting. We got a little bit more than we bargained for, and that's actually because of that wraparound logic. So like as I get down to the bottom and stuff, it's actually wrapping around to get some more of these color values. But this is starting to look kind of flamish. Let's go through and let's tweak this divisor though. Let's see what happens. So I have value 4.25. Let's try like 8.25 and see what happens to the picture here. So I do that, and hey, this is kind of interesting. Like now there's a flame effect for sure, but it looks like it's less intense here. And let's see if I run this again. So yeah, I get a different value here. It's interesting how they're all kind of gravitating towards the top here. And I think that's just because it's how, or it's overwriting my bottom row here, and it's actually wrapping around. So you're seeing some weird effects of the wraparound here. And actually this might be because I don't think I want to apply so one little thing that they weren't super clear on. So if you look at my code right now, I'm looping through every X position and every Y position, and I'm computing the pixels based on the sum of all the pixels here. But if you look at their code, they're only going from the top, like Y position 0, to the height, like the height -1 actually. So they're going down to the second to last row. They're not actually touching the last row, and that's because the last row they set to that random value. So I forgot to do that here. I actually want to go my height -1, so I want to skip the last row. So this last row should just be random color values, and then the other ones now should kind of pull in their colors. So now if I run this, we should hopefully see, yeah, there we go. So now you can see how this value is kind of is that random value that we saw before, and it's influencing all of the other values that I see here. Now it is interesting though that this top row is getting influenced quite a bit by the bottom row right here, and I don't understand exactly why that's happening right now, at least intuitively. I didn't really step through this frame by frame before, so I don't know, let's roll with it. We'll see what happens. So the next step now is I just want to just keep running this logic, just make this animation work basically. So let's put this in a loop now and see what happens. So for my loop, let's start it right here. So we'll say while true. And remember, the first step in my loop is I'm always just going to blow away the bottom row and set it to these random values. So I'm going to keep that. And then we'll say, let's perform a step of flame intensity calculation. So we're going to do this right here. And then I also want to do this step right here where I go through and convert all of my pixel values into colors that I display on the screen here. So let's save this and let's see what happens now when I run this. And I'm going to use the -n option because now that I have an infinite loop, my program's never going to return. And so -n just says run my script and don't wait for the output for it. So I'll do that. And okay, so things are happening here. It is interesting. I must have made a mistake here because I did this code ahead of time and it wasn't flipped around. So let's look and see if I can figure out my mistake for this. But we do see a fire effect happening here. It's funny though. I've managed to invert this on accident. So let's see. I must have made a mistake potentially in where I'm storing the intensity values, which I don't think I am. So like y times my width plus the x position. I think these intensity values look okay. And then maybe I'm making a mistake right here. So I go through my pixel width and my height values, and I take my y value times my pixel width plus the x value, and I look up inside of here. So let's see. So someone's mentioning, I think you need to be doing +1 on the Y. Oh, you're right. Thank you, Drew the Ogre, if that's your name. Thank you for catching that. Yeah. So this is a kind of a no duh. So I was basically saying I'm computing each of the pixels. I meant to say looking at the pixel below it, but I forgot that the top row is row 0, the one below it is row 1, row 2. But I was subtracting right here, so I should be adding instead of subtracting. So that was the mistake I made here. So hey, this is useful. This is pair programming. Okay, so let's save that. Now let's see what happens when I run this. So we should hopefully see. Yeah, that looks more like a fire effect to me. So that's kind of cool. Thank you for catching that. That was that's the kind of little mistake that probably would have taken me 20 minutes to figure out. So okay, so that looks cool. Let's play more with this divisor value. So let's go back to 4.25 like we had before right here, and let's see how this changes things. So I'm gonna do this, and now it's like, whoa, it's really bright. Like it's mostly white values. So it does kind of match, like they said in the text. The higher this divisor, the smaller your flames. So, divisor of 4 isn't really good for this display because this display isn't very tall. 8 looked pretty good, but let's go to like 16.25. And you don't have to put 0.25, like we do 0.33 if you want. Any kind of value inside of there you can play with. So let's do that. And now we get, these look like these are a little bit smaller flames. So you still have that kind of bright, really intense white value at the bottom. But now at the top, you can see it fades up to, there are even like some blank pixels at the top. So that seems a little more fire-like to me. So that's looking pretty good. Now the one thing that I didn't like when I did this earlier, I don't actually like this bottom row on the NeoPixels, because when it's a white pixel, it's really bright. It's like your eye just focuses on that. So what I was thinking was, let's modify this so that my fire matrix has one extra row at the bottom. And that's going to be my random color row, but I'm not actually going to show that row on the pixels. So, I'll still have all those values, but I'm just going to see the top half, like what my finger's covering up right here. And I think that'll give me a little bit nicer display that's not so like, whoa, bright, in your face kind of thing. So let's modify our code to do that. So for my fire matrix then, I need to change it so that it's pixel height +1, so it has an extra row down at the bottom here. Now for my bottom row, its value is now pixel height because my total length is pixel height +1. So now pixel height is the bottom row. This step is exactly the same, although now I actually want to go all the way to pixel height instead of pixel height -1, because I'm basically just adding 1 to the size of my the height of my matrix here. And then I want, in this very last step, I want to be careful because my NeoPixels don't go down to that row. That last row I want to skip. So I can just say, go from Y, or actually no, this should be okay. I still want to do the exact same thing here. So I'm just going to loop through all of the visible pixels and display them on my NeoPixels here. So let's save this and let's run this now. Let's see how this changes things. So, okay, that looks kind of nice now. That's, not as intense, but you do see some more colors that are kind of animating. And then let's go back and change this divisor. Let's make it a little bit smaller because, now I have an extra row at the top that I'm not getting. So let's, I just said it's like 12.33. So let's do that and let's run this now. And hey, that's looking pretty cool. So, now I don't see those super bright pixels at the bottom. And it's a little hard to see on the camera because it's like trying to fix the exposure, but this looks really nice to me. Like it's a it looks very kind of seasonal and, like a happy Christmas or holiday scene. You've got a fireplace in the background. You've got these nice kind of yellow, orange pixels at the bottom, and then red and less red pixels at the top. And it's all just kind of animating, relatively smoothly. It definitely is kind of organic. Like there's a lot of randomness to it, but everything kind of flows up, and there aren't a lot of pixels, so it's hard to see. When you look at the examples they show right here, there are a lot more pixels, so you can see kind of the flames changing a little more easily. But I think this works. I think this is mission accomplished on getting this graphical effect to work. And the cool thing is, like, I can change these parameters if I want to, to play with how these values, maybe this is like a more intense, how about, let's do like 6.33 for this. So let's see how this changes. So, I should have like much brighter flames now. So, oh yeah, look at that. Now I've got like some white pixels down here. That's kind of cool. What if I go a little bit taller, like 7.33? This might be the magic value. You know what? How about this? Let's do 7.77. That seems like a lucky number. So we'll do that. And that's going to give us, hey, that looks pretty cool. I like that. That's, pretty much the whole thing is filled up with some nice, like it's yellow and orange and a little bit of white at the bottom and then red kind of at the top. That's looking pretty good to me. So cool. So that was it. I think this is the end of the stream. At least I'll wrap things up. If folks have questions, maybe throw them into the chat. And I'll post a link to the code for this as a gist on GitHub when this goes up on YouTube. Look in the description below, and I'll have a link to the code. And just an FYI, if you are going to use this on an RGB and not RGBW matrix, you do need to change this HSL to RGB function. Just pull out this last component right here. I'll show you what happens when I do it on my display. You're going to get weird values because these pixels don't work when you only send, or actually you get nothing. So yeah, it's completely broken at that point. So, but just an FYI, if you're not using the RGBW pixels, you might need to change that value. And then you also need to change how you initialize the NeoPixels. Like I'm passing in 4 components per pixel instead of the default of 3 for this. So, but again, that's the fire animation effect. So it's pretty cool, and it's amazing to me, again, how just that simple little rule of just setting each pixel based on the pixels around it and just applying that logic over and over, and then using that color palette that you set with a nice color gradient. Oh, actually, I just remembered. So at the beginning, I said, let's try and mess with the color of this fire. So let's try that. I didn't try this earlier, but let's see. So, this hue value is what I'm going to use to set my the colors. And so it just so happens they're picking a hue that goes from 0 to 85. But let's offset it. Let's go from 85 to like 165 or so. So I'm just going to add 85 to the value that we had before here. So let's save that. Well, let's see what happens. We're going to get some different color. I don't know. Maybe it'll look good. Maybe it won't look good. Oh, wow. That's cool. This is like a green flame, the green fire. It's like bluish green at the bottom and then a more true kind of greener green at the top. That's kind of cool. Let's try like, let's add 100 to this, or let's do like, how about 160 plus up to like 85. Let's see how this changes the colors now. So this is, oh, hey, this is cool. This is like more of like a bluish flame. It's like a whitish blue at the bottom. A little bit hard to see because if I remember correctly, our eyes see blue in a different way than other colors. Like blue things look more intense to us. So there's actually probably less blue values inside of here, but my eyes just see it as blue. And that's because there's a whole thing called gamma correction, which actually corrects for that. And I'm not doing that. And so that's why blue colors can look a little more blown out and brighter than they really are. Because your eyes interpret, you don't have a linear response. You actually have more, I think, certain color receptors in your eyes than others, and so there's a non-linear curve that you apply for some of that stuff. But that's kind of neat. So you can just mess with offsetting the hue to change this value. Let's try like I don't know, how about 77 plus this? So this will be kind of in between some of the values that we saw before. And see how this changes it. So okay, yeah, this gets us back into the green kind of zone. So this is, yeah, the alien campfire, someone described it as. That's a good description. So that's kind of cool. So this is holidays on I don't know, let's say Venus or some other planet where it's probably different color atmosphere or something. So okay, cool. But let's go back to, this is the Earth holiday. So we'll go back to the red flames here. So cool. Okay, so yeah, I don't see any questions, so I'll wrap up this stream then. We'll go back to the main shot. Actually, here, let's keep it on the workbench, but we'll put the head in the lower right. So there we go. So we'll just kind of move that over there. So excellent. So thanks a lot for watching. This is Tony from Adafruit. This was the MicroPython holiday NeoPixel fire animation. So we took the demo scene fire animation effect, saw a really nice description of it, and a C implementation and turned it into a MicroPython implementation. And it runs pretty well on the ESP8266. So you've got a nice little desktop fireplace that you can create. 3D print a little mantle to go around this, and you're good to go. You can have a nice, calm, serene fire on your desk anywhere without setting anything on fire, luckily. So thanks a lot for watching. Tony from Adafruit. So check out youtube.com/Adafruit. You'll see this video and all kinds of other fun project videos. Check out twitch.tv/Adafruit. That's where I stream these things live. I usually do a couple streams per week, but we've got the holidays coming up, so I just did this one stream this week. Next week, I'm not sure if I'm going to have any streams. The later half of next week, for sure I won't. Maybe early in the week I might get in another stream. So for the next couple weeks, I might not have any streams. But after the new year, we'll come back and we'll have all kinds of fun new projects. So keep your eyes peeled for more great stuff. And if you like this stuff, if this is useful, click the like button, comment, let us know this is cool stuff. Subscribe to the channel and you'll see all kinds of more fun stuff like that. So let us know that this is good stuff and we'll keep making content like this. So thanks a lot and have a good holiday also. So whatever you celebrate, enjoy it. Or even if you celebrate nothing, just have a good couple weeks and we'll see you after the new year. So until next time, this is Tony from Adafruit. Thanks for watching. See ya.